Hello students, my name is Rajkumar Gupta and I am working as an assistant professor in the department of MCA in IIMT College of Engineering Greater Noida. Students, today we will study about the process, which is a very important topic in the paper operating system, and you people must know the information what is the process and how it is executed by the system. So there are some slides that I have discussed in front of you, and the topics I have mentioned here. The first one is a definition, PCB, life cycle, scheduling type, and what is the working of the scheduler actually. So firstly, we must know the definition of the process. What is the process? Basically, as we all know, the process is an instance of a program that is being executed. Mean to say, as we all know, the program is basically the collection of instructions. Instructions means in the program you are typing some code. That code is known as instruction. That the mean to say the collection of instructions is known as program. Dear students, when that program is going to be executed by the system, then that program becomes the process. In other words, we can simply say the program which is in execution state. Listen it very carefully. The program which is in execution state is called a process. In other words, we can simply say process is that when the program is executed by the CPU. Clear? I have also mentioned here the program is loaded into the memory for the execution, then it also becomes as a process, right? It is more than a program code, which is also known as the text section. It includes the current activity as represented by the program counter and the contents of processor register. Dear students, when the process is loaded into the memory, when the program is loaded into the memory, then in that case it will be divided into the four sections. The first section I have mentioned here, that is called stack, heap, text, and last one is data. Clear? So we will study in detail about stack, heap, text, and data. Students, what is the stack? In context to the process, text stack means it contains the temporary data like functions, methods, parameters, return address, etc. and etc. Now come to the next point, that is called heap. What is heap? As we all know, as we have studied in our paper, that is the data structure paper, data structure and analysis paper, stack, heap, both the things we have studied in that paper. But we are talking about in context to the operating system, then the meaning of stack and heap is different. As we all know, is heap is also a data structure, stack is also a data structure. So stack means in this section it contains the temporary data. As I have told you, it will contain the functions, parameters, etc. and etc. Now we are coming to the heap. Heap, what is the heap? It is dynamically allocated memory allocation. Dynamically allocated memory allocation mean to say there are two types of memory which are allocated to the variables. That is, first one is called dynamically allocated and second is will be statically. Mean to say runtime memory, runtime and compile time memory allocated to the process. But if we are talking about in this section, then it will be dynamically allocated, mean to say runtime allocation. As I have told you, the process will be in runtime, mean to say program which is in execution, which is going to run by the CPU is known as process. Definitely it will be a runtime dynamically allocated memory. Okay, next one is text. So what is the text? We must know what is the text. Text, as we all know, Text mean to say some characters, some letters that we are going to type, but in this section it will not be. Mean to say what it will be, it include the current activity. Current activity, dear student, what is the current activity? That will be represented by the value of PC. What do you mean by PC? PC mean to program counter and the contents of processor register, right? So there are the three sections you have studied: is stack, heap, text, and last one is data section. The data section contains global and local variables. The question arises here, what is global and what is local variables? As we all know, if you are going to develop a particular program, then in that case you have to declare the variables in that program, right? So there will be the two type of the variable. First one is the called local variable and second one be global variable. My dear students, there is basic difference between the global variable and local variable. The basic difference is that the variables which are declared inside the or within the main function is called local variable to the function. But if the variable is declared outside the main function, then that variable will be global variable for the main function, right? This is the basic difference, these two. So my dear students, I think you must know about the basic definition, what is process, what is difference between process and program, how the process is loaded, and how the process will be divided into the different sections. Clear? Now we will move to the next, that is PCB. As we all know, what is PCB? PCB is, I have mentioned here, you can read it. PCB means process control block. Dear students, there are so many processes which are to be executed by the CPU. The processes are kept in a pool. Listen it very carefully. All the processes are kept in a pool. That pool is known as job pool. Clear? All the processes are kept in a pool and that pool is known as job pool. Clear? From the job pool, all the processes will be picked up by the scheduler for its execution. Okay, and in that case the process has to be maintained in a particular data structure, that is known as process control block. Process control block means all the information regarding the process, all the information. We will discuss about the information, what are the information, what may be the information of the process. That means all the information will be kept in PCB block. Clear? It is basically the data structure of it. Okay, so you must be clear about the PCB. PCB means it is a data structure that have all the information of the process. Clear? And next thing is that the process diagram figure, process control diagram figure. Basically, this is a process state, process number, program counter, registers, memory limits, list of open files. So dear student, you must know the meaning of each activity which are shown here. First one is process state. Process state. There are so many states in process. We will discuss it in our next slide. What is the process state? There are the 5 states actually. We will discuss it later on. So this is called the process state. Now come to the next point, that is process number. As we all know, serial number, roll number, sequence number. In the same way, there will be process number. It may start from the sequence 1, 2, 3, 4, 5, 6, 7 and so on. Clear? The program counter. What do you mean by program counter? As I have told you in my last slide, program counter means which instruction is to be executed next. It will be accomplished by the program counter. It will keep the record of it. Clear? Now the registers. What are registers? Actually, when the CPU is going to execute any process, any task, then there are so many registers within the CPU. So these registers are those registers which are actually known as, we can simply say the registers are also known as the CPU registers. Next is memory limits. My dear students, when the word comes memory, memory is basically used to save the data for the future use. It may be temporary, it may be permanent. So all the memory management scheme like save the data for temporary use, save the data for a long period of time, it will be accomplished in this section. My dear students, actually I want to tell you one more thing. Suppose you are having some information in secondary drive. Listen it very carefully. Your information will be in secondary drive. For example, you are having some information in hard disk. That information will be picked up by the CPU in main memory. Listen it very carefully because it is a very you can simply say it is a very deep knowledge about the execution of any program or any process. When the when the process or program or whatever the data you are having in your secondary device, that will be picked into the main memory. From the main memory, that data will be accessed by the CPU, but it will not be directly. One memory will be there between the CPU and the main memory, between the CPU and the main memory. Listen it, these two words, CPU and main memory. The memory name is cache memory. Cache memory. So what it will be, from the secondary drive, the data will be from secondary drive to main memory, and after that main to cache memory, and cache to CPU. Cache to CPU mean to say, in simple words we can simply say the data which is going to be executed immediately, the data which is needed to execute immediately, that data will be kept in cache memory, and always the data will be picked up from the cache memory to the CPU. So this is the main concept of the main memory, CPU and secondary memory. As we all know, main memory, cache memory, both are the primary memory, and we all know primary memory is a temporary memory. Clear? So all the memory management scheme will comes under the memory limits. Now the list of open files. What do you mean by list of open files? There will be some accounting information, some security information. That files will be kept under this section. So I think this topic, this block, with the help of this block diagram, you are able to understand what is the process state that I have told you. I will tell you later in my next slide. Process number mean 1, 2, 3, program counter, the instructions which are going to be executed, register, CPU register, memory limits, memory management scheme, open files for maintaining that particular file, the information of those files. So this is the simple and basic diagram of process control block. Now come to the next slide. My dear students, as I have told you that we will discuss the states of a process. So there are 5 states that we have declared here. First state is, as you can see and you can read out, the first stage is new. What do you mean by new state? As I have written here, when the process is created, or the process is initialized, in that case the process will be in new state. We can say the process will be in new state. So this is called new state of the process. Next state is ready state. When the process is created, simple meaning is that this process needs CPU for its execution, but it has to wait for some time. It have to wait for the some time for its execution. In that case, the process has to wait for what? To have the CPU, to hold the CPU. In that case, if the process is waiting, listen it very carefully. These are very simple concept that I am discussing with you people. The new state, when the process is created or when the process is initialized. Ready state, if the process is waiting for holding the CPU. Clear? For what holding? Because it wants its execution. In that case, the process is will be in ready state. Running, you can simply understand. In this case, the process holds the CPU and start its execution. When the process is executed by the CPU, then that state of the process is called running state. Next state is blocked state. Suppose the process is in running state and it needs an event or a particular resource, then it will be the blocked. It will be in blocked state. Or we can simply say, if the process is going to be executed at the same time, some event may be occur, another process may come for holding that particular resource. So in that case, that process will have to wait for some time for the event, for giving the authority of CPU to the another process. In that case, it will be in blocked state. And my dear student, last state is terminate state. Terminate state means the process has completed its com complete execution. Clear? The mean to say, the process is being executed and provide the result, whatever the result we have want from the process. Clear? These are the 5 states. We can understand it with the help of a block diagram that I have discussed here in front of you people. So there are 5 states. First state I have discussed here, start. Start means the process is being initialized, the process is being created, and after that, from the new state, we can, I have discussed in my previous slide, this one, if the process will be in a new state, that means to say, from the start initial state, that will be in new state. Okay, so from the start it will go to the ready state. Ready means the process has to wait. Listen it very carefully. From this diagram, you people are able to understand the complete life cycle of a process, and you will be able to understand it. Clear? So from the start, from the new state, it move to the ready state. In ready state, I have told you, I am repeating my sentence again. In ready state, the process have to wait. The process have to wait for acquiring the CPU to complete its execution. So here we have discussed here ready state from start to ready. Clear? In ready state, the process has to wait for the CPU. When the wait time has been finished, then it will go to the running state. In running state, the process will be executed by the system, executed by the CPU. But at that time, if any process with higher priority, I am talking about the priority, or any event have to occur, then this process have to move in this state. That will also known as blocked state. And here we have mentioned here wait state, mean to say, if any other process want to hold the CPU at the same time, then this process have to come here, come in this state, and it have to wait until and unless the resource will be free. Mean to say, from ready to running, after running it may come to wait state, and waiting to ready, and again when the CPU will be free, it will go in running state. Clear? When the when CPU is executing that process, and when the execution is complete, then it will move to the terminating state. Mean to say the process completes its execution completely. Clear? My dear student, I'm thinking that you should have no problem to understand the diagram. Now there are so many processes. There are so many processes, as I have told you in my before some time. They are kept in a pool that is known as job pool. So which process should be executed, which process should be executed firstly, should be executed last? So there are so many. Scheduling, what is the schedule? Firstly you should know what is the scheduling. Scheduling means you the process have to execute it in a sequence, in a proper manner, right? That is called scheduling. So there are two types of the scheduling. First type is preemptive scheduling and second type is non-preemptive scheduling. So my dear students, firstly I will tell you about the preemptive scheduling and after that non-preemptive scheduling. Clear? I have written here, used, it is used when a process switch from running to ready state or from the waiting state to ready state. Listen, my students, I will tell you in very general way. Suppose the process is executing by the CPU and at that time another process want to acquire that CPU. Listen it very carefully, you will be able to understand the preemptive scheduling concept. One process is executing by the CPU and at the same time another process want the CPU for its execution. In that case, suppose for 5 seconds there are two processes, the process 1, process 2. So the CPU, what will the CPU do? If in that case CPU may do for 5 seconds, it will execute the process P1 and it will go to the process P2 and execute that process for 5 seconds and again come back to P1 for 5 seconds, then again go to the process P2 and execute their process for 5 seconds. Clear? Mean to say CPU is switching from process 1 to another. But this switching will be to complete the execution of these processes. Mean to say when the CPU is switching, listen it very carefully, when the CPU is switching from one process to another process, then this is known as context switching. Clear? And in this case the process state may be changed, as I have told you, from running to ready. If the process is in running state, then it will be in ready state because another process is being executed, or it may be in waiting state. So in this case the CPU is switching. Or in other words you can say when the CPU is switching, then this is called the preemptive scheduling. Now next scheduling is non-preemptive scheduling. Clear? So what is the non-preemptive scheduling? As I have told you about the preemptive, suppose we are having P1 and P2. I am talking about in the same sense with respect to non-preemptive scheduling. Mean to say, suppose the process P1 is holding the CPU and at the same time the process P2 wants the CPU. But if the scheduling is non-preemptive, then until and unless the CPU will not be free, the CPU will not be free until and unless it complete its execution, or it will execute the process P1. If the process P1 has been completed its execution, then CPU will switch to the another process. This is the main difference between preemptive and non-preemptive scheduling. The examples I have written here of the preemptive scheduling, you can read it out, or in non-preemptive scheduling you can also read it out. There are so many algorithms, we will discuss this later on or in upcoming lectures. Okay, so you must aware about the preemptive scheduling and non-preemptive scheduling. The question arises here, who schedule it? The question arises here, who will schedule it? Who will decide this will be a preemptive? Who will decide this will be non-preemptive? And the scheduling is accomplished by whom? So for this purpose, the scheduler is used, right? The scheduler is used. The work of schedulers is to schedule the particular jobs or to schedule the particular processes. So you can read it out. Basically, these are the system softwares which is used to submit the jobs, which is used to submit its job, or you can in other way we can simply say the schedulers are used to schedule the process for its execution. So my dear students, there are three types of the scheduler. First type is long-term scheduler. Long-term scheduler, in simple way we can say it will be a job scheduler. Mean to say long-term scheduler work is to admit or to the long-term scheduler, the long-term scheduler, as I have told you, it will be a job scheduler. The work of long-term scheduler is, what is the work of long-term scheduler? It select the process from secondary to main memory. Listen it very carefully. From secondary to main memory, it will be accomplished by long-term scheduler. Mean to say it, I have also mentioned here, select the process from the queue. Queue means secondary and loads them into the memory. Memory means primary memory for its execution. This is the basic work of long-term scheduler. So what will be the short-term scheduler and medium-term scheduler? From the short-term scheduler, actually this question is has been many times asked, what is CPU scheduler? CPU scheduler is also called long-term scheduler. Many times they are asking in different interviews. So you will be aware about the second name of the schedulers. So when the process comes to the main memory, as I have told you, if the process is in main memory, then the work of this scheduler has been started. Okay, scheduler, it select the process among the processes that are ready to execute and allocate CPU to one of them. Clear? The process are in main memory or in the particular state, then the work of short-term scheduler is to give or to provide CPU for its execution. Now the third term is medium-term scheduler. Medium-term scheduler is basically, you can simply say, in this case the CPU is switching. It is known as the context switching, as I have told you. Medium-term scheduler, in any particular state, if another process comes or an event occurs, then it will, in this case it will the process have to wait for some time, and that waiting will be accomplished by the medium term scheduler. My dear students, you can understand it with the help of a suitable diagram. The diagram is given here. This is the job pool. Listen it very careful. This is the job pool. From the job pool, the long-term scheduler selects the jobs and take it in ready queue, right? From secondary to main or from job pool to ready queue. The work of long-term scheduler. It will be the work of long-term scheduler. Now, from ready queue, mean to say in ready queue the process is waiting. The process is waiting for the CPU, and to assign the CPU for the waiting process will be accomplished by short-term scheduler. That from ready to CPU, it will be accomplished by short-term scheduler. Now, if any input-output event may occur or any process may become for like a priority, then in that case CPU, the process will come here and it have to wait for input and output events, and this will be accomplished by medium term scheduler. Okay, and there is no event, then CPU completes its execution and finally we exit here. Okay, so these are some basic information of the process and its states and whatever the details about the process. In my upcoming slides, we will discuss more. Thank you and have a nice day, my dear students.